Okay, Mr. Masseroni here with part two. We're going to start with sums of finite, check that, finite arithmetic sequences, okay? And we just start out with a formula. Finite sequence, the number of terms, S of n, so the sum of the number of terms, is the number of terms over 2 times the quantity of a1 plus a sub n. Okay, the numbers in the parentheses are the first and last term. So we take the first term, the last term, add them together, multiply them by the number of terms divided by 2. Okay, and the best way to go through this is an example. Find the sum of the first 1,000 positive terms. And what I like to do is write the formula. N over 2, a sub 1 plus a sub n. And you get 1,000 terms. So the sum of 1,000 is 1,000 over 2. The first positive integer is 1. The last positive integer is 1,000. And we can always do that on the calculator. Okay, we've got alpha y equals 1 to get our fraction 1,000 over 2 times 1 plus 1,000. And our answer comes out to be 500,500. Okay? So very simple calculator work. I'm not always going to do that, but to show you the calculator buttons is great, but I assume you know how to do it. If there's anything new that you don't know or might not know, I will definitely put that in there. Now, find the sum of the first 15 terms of the sequence, 4, 7, 10, 13, and on and on. And what we don't have here, okay, here's our sum formula, n over 2, the first term plus the last term. We don't have the last term. We don't know what it is. We know it's the 15th term, okay, so we have to figure that out. And the easiest way is from the last lesson to use the recursive definition. We know our difference is 3. We're going up by 3 every time. So if we go back and you remember, a sub n is your first term plus n minus 1 times the number of differences. Okay, so if I want the 15th term, I take my first term, which is 4, plus 15 minus 1 times 3. And when you put that all in your calculator, you should have no problem getting 46. So we come back here. The sum of the first 15 terms is 15 over 2 times 4 plus 46. And your trusty Texas Instrument calculator will give you 375. Okay? Now we're going to switch over to geometric sequences. A geometric sequence exists if the ratios of consecutive terms are the same. Okay? Now before, when we did arithmetic, okay, we are doing repeated addition. And repeated addition is just multiplication. You don't see that off the page. It's just multiplication. Okay? For geometric, you're doing repeated multiplication, and that is exponents. That is a power when you multiply the same thing over and over and over. Okay? So what you see here, and I'll show you a few examples here. Write the first 5 terms of a sequence where the first term is 9 and the ratio is 1/3. So your first term is 9, nice and easy. Your second term is your first term times 1/3, and you get 3. And as you go, you keep taking your terms, multiplying by 1/3, because you have repeated multiplication. 1 times 1/3 is 1/3. And then your fifth term is 1/3 times 1/3, which comes out to be 1/9. Okay, and there are your 5 terms. Now to find the nth term of a geometric sequence, if you remember what we did, the recursive definition, we did one fewer difference. We're doing the same thing. Here, let me get up there. There it is. We're doing the same thing. We're doing one fewer ratio than the number of terms times your first term. Okay? Pretty straightforward. Best way to do this is to give you an example of it, and I've got a couple right here. Given -3, 6, -12, find the 8th term. The first thing you want to do is find your ratio. 6 divided by -3 is -2. -12 divided by 6 is -2. Always check it. So your ratio comes out to be -2. Again, I like to always write out my formulas. Helps you to learn them better. There it is. So I want the 8th term, my first term, times my ratio to the 8 minus 1 power. We put that in our calculator. -3 times, now when you have a negative number to a power, make sure you were putting that in parentheses or you will get a wrong answer, you'll get a wrong sign. Okay, you put that in and what do you get? 384. Perfect. Very simple. 384. Now, change it up on you a little bit. I gave you the first term and the 4th term and asked you to find the 10th term. What I didn't give you was the ratio. So how should I do that? Well, we know that to get to the 4th term, you take your first term and then you do 4 minus 1 ratios. You have 3 ratios, your first to second, second to third, third to fourth. Okay, you know what all these numbers are. 125 is 8 times r to the third. Now it's just a matter of solving that. Divide by 8, you get 125 over 8 equals r to the third. Now on your calculator, if you hit, I'll start over again, the math button here, you'll notice number 4 gives you a cube root. If not cube root, you can always raise it to the 1/3 power. If you're looking for the 4th root, it's the 1/4 power. Okay, so I want the cube root of, get my fraction, right? 125 over 8, alpha y equals 1 to get your fractions. 125 over 8. And my answer comes out to be 5/2. So my ratio is, here, let me write that so you can see it a little better. Ratio is 5/2. Now I'm looking for the 10th term. So a sub n is a sub 1 r to the n minus 1. My 10th term is my first term, which is 8 times 5 over 2 to the 10 minus 1. Again, you can put that right in your calculator, and you are going to get, well, here, let's do this, because I want to show you something here. 8 times alpha y equals 1, in parentheses, 5 over 2, come out of the fraction, and the parentheses. Now I go to my exponent, 10 minus 1. And when you hit it like that, it gives you a decimal. Now that decimal, math, enter, enter, it still gives me the decimal. That's odd. Okay, I can tell you what that decimal is, what it should be as a fraction. 1953125 over 64. I'm going to have to look into why that gave me a decimal. I prefer fractional answers. They are exact. I'm not sure why my calculator gave a decimal. I'm going to have to look into that, probably because it's my calculator. It's an older model. I probably have to update it. I apologize for that. But I've given you the fractional answer. Mr. Higgins will make fun of me about this. I'm okay with that. All right. Now I want to insert 2 terms between 8 and 64. So 8 is my first term, another term, 2 terms, and 64. So this is my first term. 64 is my fourth term. So I have to go ahead and find the ratio. What am I going to multiply 8 by to get my second term? Okay, so we will use a sub n equals a sub 1 times r to the n minus 1. So a sub 4 is a sub 1 times r to the 4 minus 1. Put all my terms in. 64 equals 8 times r to the third. Divide by 8. I have 8 equals r to the third. Take my cube root. My ratio is 2. Now I have to find the two terms. So 2 times 8, 16. 2 times 16, 32. 2 times 32, 64. Perfect. Okay? Now we're going to move on to the sum. A finite geometric sequence and an infinite geometric sequence. A finite is one that ends. Infinite goes on and on. So when you're looking for the sum of a number of terms, you take your first term and then a fraction 1 minus your ratio to the nth power over 1 minus your ratio. And for an infinite, it's just your first term over 1 minus your ratio. It makes it a little simpler there. But the issue is you have to know which formula to use. We'll help you with that. If you look here, your next example, see it goes from 1 to 10. So it ends. So it is a finite sequence. So what I want is 10 terms. My ratio is this number, the repeated multiplication is 1/2. Now your first term is 16 times 1/2 to the first, which is 8. Okay, so the sum of 10 terms, you want to make sure it's your first term times 1 minus your ratio to the number of terms over 1 minus your ratio. So your first term is 8, 1 minus, and we said the ratio was 1/2 to the 10th over 1 minus 1/2. Okay, and when you put all that in your calculator, that comes out to be a little bit of an ugly number. 1023 over 64. Okay, get some practice putting that in the calculator. If you need me to go over it, I will. All right, the next example. Find the sum of the first 12 terms, and I've only given you 3. Okay, we have to find our ratio, and in order to do that, we divide. -15 divided by -3 is 5. -75 divided by -15 is 5. So it all checks. We've got a ratio of 5. So, sum n terms, your first term, 1 minus r to the n over 1 minus r. Your first term is -3. Where I want the sum of 12 terms. And my ratio, 1 minus 5 to the 12th power over 1 minus 5. And again, in your calculator, you come out with -183,105,468. -183,105,468. Okay, again, one of the things about pre-calc is you get some ugly answers like that. But since this is an all-inclusive school, all numbers are numbers. We don't discriminate. Decimals, fractions, large, small, we love all the numbers. All right, find the common ratio of an infinite series whose first term is 4 and whose sum is 8. So it's an infinite series. That is kind of a much easier formula to work with. Your first term divided by 1 minus your ratio. Now I have 3 variables. They've given me 2. My first term is 4. My sum is 8. And I need to find the ratio. Okay? Now, when I look at things like this, I make it easier. I turn everything into a fraction. You've got a variable and a denominator. All I'm going to do is cross multiply. 8 minus 8r equals 4. Okay, you guys have all done this to solve your proportions, the little helicopter propellers. There we are. I like dealing in positive numbers. At the same time I subtract 4, I'm going to add 8r. Okay, and what I end up with is 8 minus 4 is 4 equals 8r. Divide by 8, and my ratio is 1/2. Very simple. We're all set. Nice and easy. All right, and then the last question. Okay, how do we know if it's infinite or finite? We've got our infinity symbol at the top, so we know it's infinite. I need my first term, so it's 18. I'm starting with n is 0. 1/2 to the 0 power. We know anything to the 0 power is 1. So my first term is 18. My ratio, which is the repeated multiplication, is 1/2. All right, so the sum is my first term over 1 minus r. So the sum, the first term is 18 divided by 1 minus 1/2 is 18 divided by 1/2, which comes out to be 36. Those are your examples. Those are your finite and infinite series. Hope everything goes well. Please remember to ask questions in class. Thanks and good luck.